Today, we will discuss the Heckman selection model. The Heckman selection model is basically used in the labor markets, education economics, and political economy, where we estimate two equations. The regression model, that is yi is a dependent variable, xi is our independent variables, and alpha is parameter, and epsilon 1 is error term. And the selection model is wi, beta, and plus epsilon 2 is the error term of the selection model greater than 0. Epsilon 1, where yi is the dependent variable, xi means all observable characteristics of the independent variable. Beta means the parameter required to estimate, and epsilon 1 denotes normally distributed error term with mean 0 and standard deviation sigma. Similarly, Wi means observable characteristics, including the overlapping variables with xi, and beta means the parameter required to estimate, whereas epsilon 2 is error term distributed with mean 0 and standard deviation 1. And rho means the correlation between two error terms, epsilon 1 and epsilon 2. If rho is positive, then we can say that there is a correlation between two models, and we can explain that the model is good, whereas lambda is our model specification, which is equal to rho into sigma, means the estimated selection coefficient. If rho lambda is significantly different from 0, then we can accept the model is fit to explain. Now we will focus how Heckman's selection model works in labor market, and we will apply it through Stata software. Now we are interested to do it in Stata software. So first of all, in Stata, we will bring a hypothetical data set from Stata memory. Now, first of all, we will go to the file, then we will go to the example of data sets. Then we will go Stata 13 manual data sets. Then we will go to the base reference manual, and then we'll scroll down to find out the Heckman data file. This is the Heckman data file. We have a two data file, women work.dta. We will use this data file, then we will click on use. Then we will return to our Stata file. We get the variable here, the country, county, age, education, married, children, select with full and wage. This data set of the women in labor market. Now we will try to understand whether education is a significant factor of ways, and we will try to understand how merit and children of a women influence the labor participation. So we first to create the labor force participation. Then we will click generate. We will generate a variable that is women labor force participation equal to wage less than dot. Then we will get a new variable that is dummy variable. We will tap the new variable that is women labor force participation is 1 and 0. Here the question is that 0 means that 20 and above aged women are not participating in labor market. On the other hand, 1 means the women whose age is 20 and above are participating in labor market. So 0 and 1 is the is a participate in labor market or not. So the women labor force participation variable is a dummy variable, and we will focus on the selection or Heckman selection model. So now, first of all, to do the Heckman selection model, we will use the command Heckman, and then we will write down our dependent variable, that is variable y, that is ways, and then we will try to understand that education, impact of education on ways, and then we are selecting here is comma, then select. The selection model is first bracket, the woman labor force participation rate is equal to the married, children, education, and age. Then we will close, and we will here to measuring two-step Heckman selection model. Now we will enter, then we will get the results. Here, the number of observations is 2000 and censored observations is 657. Uncensored observations is 1343. So you can see the uncensored observation means those observations who are participating in labor market, and censored observation is equal to 657 means those are not participating in labor market. Here world chi-square is very high, and probability get the chi-square is 0. This means the selection model is very good. And now we will focus then the lambda. Lambda is 4, the coefficient of lambda is 4.001. This means, and this is 1% level of significance. This means the model is acceptable, and rho is 0.672, which is greater than 0. That means there is a correlation between two model, that is wage model and labor force participation model. So the variable, overlapping variable we have used in the selection model has an impact to understand why the labor force participation increases or decreases of the women. So now the question is that rho is positive, and there is a positive correlation between the two error terms, and lambda is also positive and significant, at 1% level. This means the Heckman selection model is good to analyze. Now we will analyze the variables of the selection model because already in a first part of this class we discuss that we should aim to estimate beta. So beta merit is 0.430 is 0.074. This means the merit women will participate, the probability of participation of married women in labor market is significantly increases, that a married woman will participate in the labor market than an unmarried woman, because married women have a several formal duty in a family. So married women will participate. There's a more higher probability, that is 0.430, means 43% higher probability to participate in the labor market. The children, that is children, this is children is more than one, or if the number of children increases in the family, the probability of women participation in the labor market is increases by 44%, and it is highly significant, and z-score value is also very strong. So if there increases children, the cost of living of the household also increases. So the both husband and wife labor force participation in the labor market increases. So the probability of a family whose family member or children is much higher will participate more in labor market. Education is an important factor. If 1% increase in the educational level or years of schooling, that will positively influence the labor force participation rate of women is over the time the women will participate in the labor market. That means if age increases, the probability to participate in the labor market of women also increases. So this is the simple analysis of Heckman's selection model. Now, why we are using Heckman's selection model? The important cause is that if we take simple regression model or Wallace model, suppose the weights and 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 education and age, then we find that here only results will be shown by the uncensored observations. That means those are participating in the labor market. But in the Heckman selection model, we can see that those are participating in labor market on those, or those are not participating in the labor market. And we can say the probability why they are engaging in the labor market from the selection model, Heckman selection model. So Heckman selection model not only consider the censored observations, but also it considered the uncensored observations. So there is no scope to drop the, the observations. So in the simple Wallace model, we have to see that there will be simple model, there will be only observations that those are participating in the labor market, or those are if we go to the education economics, those are those have a score, or those have not scored, those have passed in examination, those have not passed in examination, those have passed the examination. In education economics, only if we employ the OLS regression, we can see that these OLS will only produce the results from those are passed in examination, but those are not passed in the examination, we can't represent through OLS. So in this case, where we want to see that yes or no, that whether they participating in the labor market or not, or whether he passed or he or she passed in the um, examination or not, then we should apply the Heckman selection model. Thank you for watching the Heckman selection model in this tutorial.